Hi guys, again I back to you with a little harder problem as an application of the disk method of volume. Then our class today about what? About calculus 2 application of integration, but today I'm gonna show you how I'm gonna find the equation of how I'm gonna derive the volume of the frustum cone. 1 second, guys. I'm gonna back to this. This is the problem. A cone of a height h with a base of radius r is cut by a plane parallel to x-axis and h units above the base, where the height h is less than the actual height of the cone. Find the volume of the solid, which is, we call it frustum cone, which is the bottom right below the plane. Here, this guy here, this guy from here to here. Then let us go back and see, just to don't forget, if you have any question, to text me or send me an email about any problem you feel that's hard. Then we're gonna find the volume of frustum cone using disk method. Don't forget to like and subscribe, like and subscribe. Let us start. Then this is my problem. Then a cone of height with a base of radius r is cut by the plane parallel to and h to x-axis and h units above the base, where h is less than h. Find the volume of the solid, which is the frustum cone below the plane. Let us take this back here and bring our solution. This is my cone. This is my cone. What we're gonna do, we're gonna find the volume. You see the space here, this small and this here. To save your time, what I did, I prepared the graph. If I'm gonna do the problem that take a long time from me in front of you, I prepared the graph. I wish the graph is very clear. Then the whole height is h, and the small height here is h, right? As you said, look here, where h, a cone with the height h, the whole height is h, the big height, uppercase, with the base radius is what, r, cut by the plane parallel to and h units above the, where h is than h from here to here. Now look here, if you need to see what I mean by this, if I'm making a graph like this to show you how this is gonna form, I'm gonna show you how this, the 1, 2 lines, look here, and if I have a line here, this line here up to here, 1, 2, 3, 4. Let me just fix my lines a little bit to make it very clear. Let me take this line up a little bit. And bring it just a little bit down. 3 units is enough. And just bring it here. Okay. You see this line, guys? We're gonna have another line, 1, 2, 3, to revolve it, because we're gonna revolve. If this line is blue, and let us make it a little dark here, and take another line from here to here. This when we revolve it, and let us just select it and make it. I'm gonna make it like this. I'm going to take this out. I'm sorry. the actual line, let's cut this line and take this line here. Just take it a little bit down and take it here. Okay, good. And make it, this is my line. This is the other line, the line I'm imagine that's gonna happen here when I revolve this guy here. Look here. I'm gonna just graph it and show you here. What's we gonna do? We're gonna do like this, and like this, like this. You can see you see me? We revolve it, right? About Y here, right? About Y axis, or you can revolve it like this way, whatever you know what I mean? Okay. And the radius here is R, that make this point R and 0. If the height from here to here is H, and the radius here is R, then make this point R and H, right? Actually, my function, the function I want to revolve is the blue one. The function I want to revolve about y-axis is which one? The blue one. If you remember from the last YouTube, we said the volume of revolution using the disk method, volume is about x-axis, this about x-axis from a to the b, fx dx square, dx square. Now we're going to revolve about the y-axis, y-axis. The only difference you're going to have is volume equal pi, and I like it, make it r, but I'm going to explain f of y, a function of y square dy. This is the same as r. You need this is the radius of the revolution, f of x or f of y, f of x is the radius of the revolution about x-axis. And the Fy, the radius of revolution about what? Y-axis. About what? Y-axis. You can see how I got this. Okay. Now, then the function we will to revolve, which is this function. You see this function? The line. R and H has 2 points and R is 0. This is my function I want to revolve. Look, the R is changed. The R keep changing. The maximum value for the R you can have, it's R. Yani R, the small r, uppercase R, keep increasing to reach what? The maximum value for R, right? And the H start from 0 all the way, the maximum is H. Then which function I need to find? The function which is the linear function represented by this line, the linear function. How I can find this? Let us see. Then to find this function, you need the equation of the line. You're passing through the equation of the line, pass through the points R0 and RH. It's a basic algebra math. It's algebra y minus y1 equal mx minus x1. Then what you need? y1, m, and x1. I kept all these three in red. y1, then y1 is 0. x1 is r. The slope is y2. If you need me to write the slope for you, m equal y2 minus y1, x2 minus x1. y2 minus y1, x2 minus 1. Now, all what you have to find is to find the function in fy. Just equate something here in the side. Why this happen here? Like I don't know. It's a lot of notes. Okay, just let us wait. Okay. I need you to remember that f of x this way. Remember, f of x equal y, and f of y equal what, guys? Most of the kids, they don't know x. f of x equal y, f of y equal x. Okay, let me just go back to my function. Just small note, make everything easy. F of x mean y. Then if I want to find what f of y, because we're revolving about x, because we're revolving about y-axis, this is my equation, pi a to the b f of y square dy. Now f of y, a over b, f of y is x square. Then I need to solve this equation for what? For x. Good. Then let me just back to my, just to make this clear. Then this is my equation that I need to find it for the line I said. Let me put everything together to see the line and move this a little bit here. Okay, you see this line, okay, has two endpoints, RH and R0. Then R0, RH, find the slope y2 minus y1 over y2 minus y1 over x2 minus x1. y2 is h1 is 0 is h, r minus r in the bottom, okay. Y minus y1, mx x minus 1. y1 is what, guys? 0. And x1 is what? R. x1 is r. And the slope h over r minus r. h1 is 0. Good. Now after this step, solve for x. Why solve for x? Because why solve for x? Guys, why solve for x? Because we revolving the function about y-axis. Then we need f of y. And f of y, as I said, is x. I have x in this equation. What I did, y minus 0, look here, equal h over r, x minus r. I solved it quick. What I did here, if you want me to explain it for you, here, just a quick, if you want, y equal h, right, over r minus r, just move the board, r minus r, if you want to see what I did, right, x minus r. To solve it easy, I multiply both sides by what? R minus r over h and r minus r over h. You see? You see, it's easy to do it like that. What happened here? This guy cancel with this guy, this h with h, then left here r minus r over h, y equal x minus r. Then I move the r from here to there, then becomes r, because it is negative, r minus r over h, y equal x. Okay. Which is this equation, which is this what? Equation. Okay, try to do it by yourself. Then x is fy, is still there, fy equal x. Then I have my function. I have the function I need to revolve, which is r plus r minus r over h, y. R is the radius of the big base, and r lower is the lowercase r is the radius of the small base. This method, fy squared pi. Now, I told this problem is very long, and most of they have it in with a sign, they have it in the test, they bring this problem out of some teachers. Volume is pi from a to the b, fy squared dy. Write your formula. R plus r minus r over h y squared dy pi. I left pi out. Now in this side of the board, I square for you this one. R plus r minus r over hy squared. R squared 2r, r minus r over hy plus r minus r squared over hy squared. Good? Okay. That's the square of this. The perfect square. Okay. Then you move all this here. Now remember, r and h, lowercase, uppercase, r and h, both, all of them constant. Don't worry about them. Now when you do the integration, r square y plus 2r, r minus rh. What integration of y? Y squared over 2, r minus r squared over h. What integration of y squared? Y cubed over 3. What's my limit from 0 to h? Again, r squared, integration of r squared is r squared y, plus 2r, r minus r over h, integration of y, y squared over 2, integration of r minus r squared over h is r minus r squared over h, y cubed over 3. Okay. Now you plug the h and the 0. Whatever you have y, you're going to change it to h. Whatever you have y, you can. Here h squared, h cubed over 3. After this step, minus 0, look here. Y minus 0 here I put when you plug 0. Because here we have y, r squared times 0 is 0. 0 times anything is 0. 0 times anything is 0. This term 0. Now it's simplification. Now you have to simplify. Now you have to simplify your algebra statement. You have to simplify it. How I simplify it? Let us see. Look. H squared and h. Cancel, left h. 2 cancel with 2. Now I have here square, and here square, and here h cubed. H cubed with h squared, only we left with h. Good. What left only? R minus r squared over 3 times h, and this 2 we out, r minus r h, and the r stays r, the 2 cancel, r squared h. Now look here, derivative. I call after this step is algebra. I call it what? Algebra. I call it algebra. I multiply, look here, r times h, r, h. I lifted the same color to see it. Minus r times r, the red and the green, r squared h. Plus h3. What r minus r squared? R squared minus 2rr plus r squared. Good. What happened here? R squared h cancel with r squared h. Now because my denominator here is 3, I multiply the first term, which is r, right? I took h first. You see the h? We have here this cancel. We took this h and this h out. We end up with r, right? r, and this guy cancel with this guy. 1/3 r squared, 2/3 r, the h already out here, r squared over 3. Now because all my denominator 3, I want to make this guy 3. This one, 3 times 1 is 3, 3. Then we took also now the 3 out. 5h over 3, 3r plus r squared minus 2r plus r squared. Now what 3r minus 2r? It's r plus r squared plus r squared. Now if you want to write it in a different form, which is just organize it, r squared plus r plus r squared. This is the problem. Imagine it took from me about 16-17 minutes to explain this problem for you. If you still have any question about this problem, I'm more than happy to help you. I'm reminding you just to subscribe and like and share with your friends if you like. When you subscribe, you will receive our new classes for Calculus 2. Thank you guys and have a nice evening actually.